Welcome back. This is Miss Sheldon. Today we are learning about inverse trig function. So you're going to look at this yellow foldable here. Go ahead and open it up. We're going to start in this top right hand corner where it says sine to the negative 1 x. So we call this sine inverse of x, and this tells us that if sine of a, so sine of this angle a equals some value that we call x, then sine inverse of x equals this angle A. So what exactly is this telling us? So if we have sine inverse of the lines BC and AB. So if this is angle A, and this is our segment that's opposite of angle A, and this is our hypotenuse, remember sine equals opposite over hypotenuse. So if we're given the lengths of these segments, then we can use inverse of sine to find what our angle measurement is. So we use the inverse trig functions when we're trying to find angle measurements. So how does this work? Well, go ahead and flip back to the front of your foldable. If we have sine of A equals BC over AB, so the segments that we just looked at, opposite over hypotenuse. And if we want to get A by itself, we divide by sine. But when we do this on our calculator, let's say I have some value that I try to divide by sine. So let's say BC over AB equals 5. If I try to divide that by sine, my calculator is going to give me an error, because we have to have a value attached to sine. This is because sine is technically a function or an operator. It's not its own value. So then what we do is, if you remember your exponent rules, we have sine the negative 1 equals BC over AB. Those signs will cancel and we're left with A. And the negative 1 tells us that that sign was dividing this value. So now we're going to look at our example. So let's look at the top left-hand side. And we're just going to practice plugging these into our calculator. So we have sine of B equals 0.87. So we are trying to find the angle measurement of B. So to find this, we're going to take sine inverse of 0.87. And that's going to equal B. And we're just going to plug this into our calculator. So on your calculator, sine inverse, cosine inverse, and tangent inverse should all be right above your sine, cosine, and tangent buttons. So you're probably going to have to hit the second button and then sine button. So I'm just going to plug in 0.87, and that gives me approximately 60 degrees. You're also going to want to make sure that your mode of your calculator is in degrees, not radians. So I should have the degree highlighted. If it's in radians, then you're going to get a completely different answer. Okay, so then sine of A equals 12 over 13. So same thing, we're just going to do sine of inverse sine of 12 over 13 equals A. So when we plug that in, we do inverse sine of 12 over 13 equals about 67 degrees. So now let's look at the inverse of cosine. So here, cosine inverse is AC over AB for angle A. Because remember, cosine is adjacent over hypotenuse. So AC is our adjacent segment, and AB is our hypotenuse. So if we were given the adjacent leg and the hypotenuse of a triangle, and we want to find the angle measurement, we're going to use inverse of cosine. So over here, let's look at our example. We're going to do the exact same procedure we did with inverse of sine. So I'm just going to hit second, cosine 0.15, and that's going to give me approximately 81 degrees. So I just took the inverse of cosine of 0.15, we'll see. And then here, same thing, inverse of cosine 91 over 109. It's going to give me the angle measurement of B. So plug it into my calculator. I get about 33 degrees. Now we'll look at the inverse of tangent. So again, if we're looking at angle A, and we want to find angle A, and they give us BC and AC, then we have the opposite side over the adjacent side. Remember, tangent is opposite over adjacent. So then we could use tangent inverse to find the measure of angle A. So now come over to the left. Same thing, we're just going to plug in the inverse of tangent of 0.75 equals A. So I go second, inverse of tangent 0.75, and that gives me about 37. And then I'm going to do the same thing here. So I have inverse tangent of 5 over 12 is going to give me the value of angle C. And so when I plug that into my calculator, I get about 23 degrees. Okay, so now let's look at an example of a triangle. So it says, determine which angle has the given trigonometric ratio. So it says the sine of the angle is 12 over 13. So remember, sine is opposite over hypotenuse. So if we have 12 over 13, then 12 is our opposite side and 13 is our hypotenuse. So what angle is opposite of 12? That's angle E. And this says the tangent of the angle is 5 over 12. So tangent, we know, is opposite over adjacent. So we want to know which angle is opposite of 5 and adjacent to 12. That would be F. F is opposite of 5 and adjacent, which means next to or touching 12. So this is angle F. So here we're going to do something similar to these examples. It says use a calculator to approximate the measures of angle G, H, and K to the nearest tenth of a degree. So we're just going to write out that the inverse of tangent 0.43 equals G. We plug that in. And that tells us that the measure of angle G is about 23.3 degrees. So here we want to find sine of h. So we're going to take inverse sine of 0.68, and that's going to give us the measure of angle h. So we plug that in. Do second, sine 0.68. That's going to give me about 42.8 degrees. Last one here. They give us that cosine of k equals 0.94. So if we take the inverse of cosine of 0.94, that's going to give us the measure of angle k. So again, when we do the inverse of cosine of 0.94, that's going to give us 19.9. So measure of angle k is about 19.9 degrees. Okay, so now we're going to use this information to solve some right triangles. So here they give us two side lengths, 20 and 21. So let's start by using the Pythagorean theorem to find the length of our hypotenuse. So if these are our legs, we know that that is a squared plus b squared equals c squared, and one leg is 20, the other is 21. So we're going to square those. That's going to give me 400 plus 441 equals c squared. 400 plus 441 is 841. Then if I take the square root of 841 and the square root of c squared to get rid of that square root, or to get rid of that square, that's going to give me 29. So my hypotenuse of this triangle is 29. So now that we have all the side lengths, we can use the inverse trig functions to find these two angle measurements. So let's go ahead and find the measure of angle D first. So let's use tangent. If we have tangent, which is opposite over adjacent, we're going to use 21 over 20. So we have the inverse tangent of 21 over 20, our opposite over adjacent sides. That's going to give us the measure of angle D. So again, I'm just going to plug this into my calculator. Second, inverse tangent of 21 over 20. And that gives me about 46 degrees. So I know that angle D is about 46 degrees. So I could just subtract 46 and 90 from 180 to get the measure of angle E, but let's use our trig functions and see how close we are. So let's use tangent again to find the measure of angle E. So if we're looking at E and we want opposite over adjacent, this time we're going to do 20 over 21. So I have the inverse tangent of 20 over 21. It's going to give me the measure of angle E. Plug that into my calculator. And that's going to give me about 44 degrees. So I'm going to go ahead and check my work by adding up these degree measurements and making sure they all equal 180. So if I have 90 degrees plus 46 degrees plus 44 degrees, I get 180 degrees. which should be the sum of our interior angles of a triangle. So we know that we did that correctly. All right, let's look at another example. So here we have this triangle, and they give us the hypotenuse this time, which is 109, and this leg measurement, which is 91. So let's find the measure of angle H first. So if I'm going to find the measure of angle H, I'm going to look at what I have in relation to angle H. So I have 91 and 109. So 91 is the leg adjacent to the adjacent to H, and 109 is the hypotenuse. So if I'm going to do adjacent over hypotenuse, that would be cosine. So cosine of H is equal to 91 over 109. So now to find angle H, I'm just going to take the inverse of 91 over 109. When I plug this in, I do inverse of cosine, 91 over 109. That gives me 33 degrees, so the measure of angle H approximately 33 degrees. Now I want to find G. So G here, 91 is opposite of G and 109 is the hypotenuse, so we're going to use sine because we have opposite over hypotenuse. So if we have sine of G equals 91 over 109, then the inverse sine of 91 over 109 is going to give us the measure of angle G. So again, if we plug that in, we have inverse sine of 91 over 109, and that gives us that the measure of angle G is approximately 57. So let's check our angle measurements. We have 33 plus 57 plus 90. That gives us 180, so we know we're on the right track. And we can use the Pythagorean theorem to solve for this missing side length. So I'm running out of room here, but I'm going to come use this top right side. So I have one leg, is 91. I'm missing the other leg, so I'm going to call that b squared. And my hypotenuse is 109 squared. So 91 squared is 8,281. 109 squared is 1,181. I'm going to subtract 8,281 from both sides. I think maybe I made a mistake somewhere. I apologize. The square root of 109 squared, or the square of 109 is 11,881, not 1,881. So when I subtract those, I get b squared equals 3,600. Then I take the square root of both sides, and I get b equals 60. So I know this side length right here is 60. So that covers everything we have for today. I will see you in class.